Hello. Well, I'm sorry we don't have class this week, but I think PCC made the right call. So I'm making some videos here for what we would be doing in our class. So I want to start by finishing lesson 1 and then we'll start lesson 2, okay? And then we'll have kind of a recap, combine lesson 2 and 3 is my plan for the class day that we get back. Okay, so let's do a little recap of lesson 1 here, and you're welcome to skip ahead if you want to skip the recap. It's up to you. Okay, so in lesson 1, we talked about theoretical confidence intervals for one proportion. We had a little review as well. So first we reviewed the difference between a statistic and a parameter, statistic being calculated from a sample, and the parameter is what we want to know about the population, okay? But it's too hard to know, so that's why we get a statistic from a sample, because we usually can't talk to everyone or measure everything in the population. Okay, so the goal is for our statistic to estimate the parameter, and that's what we're doing with a confidence interval. We're giving a range for our parameter. Okay. Then we also reviewed the normal model and how to find probabilities. So remember, we put the mean in the middle and we count by the standard deviation. That's our scale. Our notation is the variable is distributed as the name of the distribution, which is normal. And in the case of normal, we have our mean and our standard deviation as our inputs. I guess I didn't write that theoretically, so let me do that. We would have x is distributed as normal with the mean first and the standard deviation second. Okay, and we just put in our numbers depending on the situation. Then we also reviewed the 68, 95, 99.7 rule. So this is true for any normal distribution, whatever the mean and standard deviation are. If we go out one standard deviation, we capture 68% of the values or area. If we go out 2 standard deviations, we capture 95%. That's really, we use that for a 95% confidence interval. If we go out 3 standard deviations, we capture 99.7% of the values. So we're using this for confidence intervals. When we want to be a certain percent confident, we want to capture, we need to go out that many standard errors to capture that percentage, whatever it is. So it's around 2 for 95%. More specifically, it's 1.96. Okay, so let's keep going with what we were doing. So then we also practiced how to calculate normal probabilities, especially because you may have calculated them in a different way in a different class. So we're using the Staplet normal calculator. So we practiced with these. So rather than using tables, cross that out, we're using the Staplet normal calculator. And then we also practice getting z-scores. And on our technology sheet, there's a reference here for you. And this is in D2L if you weren't in class. Here's the link, and then here's the guideline for how to do it. You're going to do calculate area, put in your mean, standard deviation, and then if you're doing between 2 values, select whatever operation you're doing here, either between, to the left, to the right, put in your numbers, and you get your area here. And it also calculates the z-scores, which is great. Okay, we'll come back to the other things on this sheet as we go forward. So we practiced how to find a z-score. You take the value minus the mean, divide by the standard deviations, and that tells you how many standard deviations away from the mean you are. So for example, with this number 10 is 1.857 standard deviations above the mean because it's positive. Okay, I left this example 3 for extra practice, so feel free to do those. I have written them out so you can check yourself here. So find first for each number in the parentheses here. First find the z value, z-score, because Staplet's going to tell you that, and then find your probability using Staplet, and you can check your z-score with that. So I'll leave that for you to try. Okay, and then we talked about sampling distributions and the central limit theorem pretty briefly, and we'll come back to this as we're going to keep using these models, so we'll keep coming back to it and reviewing a little bit more each time. We had this in 243, we do distributions of the means and also proportions. We're just doing proportions right now. So this is if we take many, many samples, the distribution of the sample proportions would have a mean of the population proportion and a standard error of the square root of PQ over N. So we're going to be using these formulas a lot. Remember, Q is 1 minus P, so you could also write this as P times 1 minus P over N. And P is our probability of success, or whatever we're looking for. That's voting for a candidate or having a working part in a factory, whatever it is we're looking for. And then our conditions are, we must have a random sample. Each subject must be independent from the other subjects. We need a large enough population. So the population must be at least 10 times the sample size. And for proportions, it's the success failure. This also determines how large of a sample we need. N times P and N times Q have to be at least 10. Okay, so then we looked at, we're using this central limit theorem. We can kind of ignore this top part. We're using the central limit theorem for our confidence interval formula. You'll see this square root of PQ over N. That is our standard error. Standard error, because we're talking about sample to sample variation. Versus the population individual to individual variation. Okay, so our formula is p hat plus or minus our critical z value. This tells us how many standard errors we're going out, and then this square root is the value of our standard error. And q hat is 1 minus p hat, so in formulas you might either see the q hat or the 1 minus p hat. Either one is okay. We're using p hat here because in a confidence interval all we have is one sample, right? So we're using what we know before from sampling distributions to know what our formula would be. Okay, and then we calculated this one. I didn't get to the condition, so we're going to do that together here. But we did go ahead and use our formula. We had 97 out of 112 students who had used a credit card to pay for books. 97 out of 112 is 0.8661. So we plugged that in everywhere for p hat, and then q hat is 1 minus that. For 95%, it's 1.96 standard errors, and I'll show you how we got that number and other ones for different levels. We calculate what's after the plus or minus, because that whole thing is the margin of error. The plus or minus part is the margin of error. And then we can go ahead and subtract and add that to get our confidence interval. So our interpretation is we're 95% confident that the true proportion of students who use a credit card to pay for books is between 0.803 and 0.9292. Okay, so what we didn't do was our condition, so let's go ahead and do that. So we must have a random sample. That's our first condition. So it does say using a sample, random sample. So I'm going to say we have a random sample. Okay, great. So that one is met. Then for independence, we need to think about who our subjects are here. Our subjects are students. So the students would need to be independent from each other in terms of how they pay for their books, right? So let's say you go to the bookstore with a friend. Does how they pay for their books influence how you pay for your books? Or let's say you're ordering your books online. Does how other students pay for their books affect how you pay for your books? So that's what we need, and that's what I'm going to write down to make this more concrete, what these conditions mean. I'm going to write down what we would need in order for this to be true, okay? So I'm going to say each student must be independent in how they pay for books. Okay, and the idea is by getting a random sample, we would ideally have that, but we need to watch out for bias in our random sampling and make sure we're using a good method and not overlooking any sources of bias. So that's why I'm being specific in writing out what we need here, okay? So we might look for groupings, for example, maybe siblings who were students might pay for their books in the same method, but also maybe not. So we want to just be on the lookout for things we should avoid or look out for, okay? The next one is large population. Okay, so we have 112 is our sample size. So our population of students needs to be at least that big, okay? So PCC must have at least 112 times 10 students. So I'm going to calculate that. I love tens because you can just add a 0 on the end. So 1120 students. Okay, I do think that is true because PCC has way more students than that. So we are selecting from a sufficiently large population. You may have heard this one before as the 10% condition. So if you want to phrase it that way, that's okay as well. And then the last one that I'm going to write in here is success failure. So that's going to be D. So N times P is going to be, well, we've got our, it's really P hat because that's all we have in our situation here. Our N is 112, so I'm going to do 112 times 0.8661. We could also use the fraction, and you might notice the 112s would cancel out. We should get around 97, but I find more people are more comfortable with decimals, so I'm just going to stick with the decimal way of doing it. Okay, so 112 times 0.8661. Yep, right about 97, so I'm just going to round to 97. And N times 1 minus P hat, or Q hat, is going to be 112. Sorry, I don't have enough space here. 1 minus 0.8661 to go across my P hat there. 112 times 1 minus 0.8661 is 14, almost 15. So I'm just going to round up to 15. It's definitely over 10, so that's what we're looking for. 15, these are both greater than or equal to 10, so I'm going to check that off as well. Okay, so really 3 of them we're checking off. Usually they'll tell us we have a random sample. Independence, we're writing out what we need in terms of independence, just to help us identify what we're looking for in the real world in the future. The others are calculations, and we're checking them off, okay? Okay, so we'll go through a few of those, and it'll get easier as we go. Okay, so that's one example of writing out the conditions, and then we use the formula to calculate the confidence interval and write the interpretation, okay? Very specific wording for the interpretation of a confidence interval. There's a few, variations here and there, but we've got to have true proportion between this and this, and then the confidence level, okay? Okay, so the next page has kind of a summary. It talks about the different notation. So let's talk about each one of these items. The critical value, and in this case it's a z-value, but because we're going to look at different situations, we'll have different distributions. So that's why we're making it a little more general. The critical value in this case is z star. That's a z-score corresponding to a specified confidence level. Okay, so I'll show you how to calculate those, and then I'll be giving you the 4 most common ones. So z-score corresponding to a specific confidence level. Then the standard error, I've mentioned that. The standard error is our guess for the standard deviation based off of a sample. So in this situation, our standard error is the square root p hat q hat over n. That's the one in the formula right there that we used. Okay. And remember, standard error is sample to sample variation. Standard deviation is individual to individual variation. Then margin of error, you might see MOE or ME, especially in the media. I see MOE more in the media. ME more in statistics. That is when you go out a certain number of standard errors times the standard error. So that's the plus or minus part. So this is the part we usually calculate. And then we add and subtract. And then the confidence interval for the true value of a proportion. This is our general formula. It's the best point estimate, or the center, that also ends up being the center of the interval, plus or minus the margin of error. So this is a general formula. We'll keep coming back to this because this could be a mean or 2 proportions or 2 means. In this specific example for a single proportion, it's p hat plus or minus z star times the square root p hat q hat over n. And that is the one that we used right here. Okay, so practice plugging in the numbers. My open math will be good for that. Give you some practice. Make sure you're getting the numbers right. So this is for a single proportion. Okay, great. So now I want to get to where we didn't get to do practice in the last class. I need to go find my notes here real quick on what numbers we're going to plug in. So there's a utility truck outside, so I'm really curious about what they're doing. I'm just kind of waiting for the next part of the storm to start and hope I keep power. Okay. Okay, so I went to this link, and it's kind of an older link. So I'm going to give you some numbers that I think was what the person who made these notes intended. So we're going to use this formula to find the sample size. And this is an unemployment rate. And the p hat, the unemployment rate they had at the time was 8%. And then we want a margin of error to be 2%. Okay, so the questions you'll see like this say, and they give you a specific confidence level. This does say assume 95% confidence. It'll say it'll give you a certain p hat, like out of a survey, 8% said this. And it's usually we're going off a past estimate because we want to determine if we want a certain margin of error, how many people do we need to have in our survey? Okay, so we're doing this calculation up front. We do need some kind of value to go off of, or sometimes they'll tell you to use 0.5 if you don't know. So I would say use 0.5 or 50% if unknown. Okay, so the question will tell you that. We're going to use our 8%. So we're going to plug in our things. And also, in my open math, it might say n equals, or finding sample size, and n is the sample size. So this is the thing we're trying to find is on the left. Okay, so I'm going to start by plugging in some numbers here. I'm going to write n equals, I'm going to find our p hat. Now we need to do everything in decimals. We always do math with the decimals, not the percentages. So I'm going to write 0.08. And then for q hat, 1 minus 0.08. If you did that in your head and wanted to write in 0.92, that's totally fine. Some I can do in my head, some I can't. That one I can, but I would just, it's also easier just to write 1 minus that number. Then our z star, I've mentioned it and it's coming up down below. I'll show you how we get that. 95% confidence, our z star is 1.96. It's close to going out 2 standard deviations, but it's not quite 2. The margin of error is what we're trying to find. We need to put it in decimal form, so 0.02. And then remember your square on the outside. If you forget the square, it'll come out way too small. That is my clue. If I get too small of a number, I probably forgot to square it. Or I maybe put in 2 here instead of 0.02. That's another thing. So if you get like a sample size of 20, that's not big enough, right? So double check your formula. Now you could put this into the Desmos scientific calculator or Desmos graphing calculator. I like a little better. You don't need the graphing part, but it lets you store more things. I'm going to use my handy dandy scientific calculator here. So I'm going to do 0.08 parentheses 1 minus 0.08 close parentheses. I'm going to open another set of parentheses, and these are 3 multiplications in a row, so it's going to do the order of operations just fine. 1.96 divided by 0.02 close parenthesis, and my square key is right here. Look for your square key on your calculator. It might also say you can also use a caret 2. Some calculators don't have a specific square. You just have to do caret 2. But this one does have a specific square button. Okay, 706.8544. I'm going to write that whole thing down. Okay, and that's what I got before. Now, we're not quite done yet because remember, this is how many people do we need to survey. So we can't survey 0.8544 of a person, right? But the thing to know is this is a minimum. So we're going to round up. And you might be saying, well, it's 0.8, so of course we're going to round up. That's true, but even if this was 0.001, we would still round up because we need that part of a person, but we need to survey the whole person. So this is a minimum. If we round down, we won't have 2% margin of error anymore. It will actually be a little bit bigger. So we don't want that. So we're saying we want, 2% margin of error. So always need to round up. So round up to the next whole number, even if below 0.5. I'll just say, and I'm talking about the decimal part, even if the decimal part is less than 0.5. So we need to survey 707 people. And I can write that out in a sentence. I'm not going to do this one. We need to survey 707 people to have a margin of error. Sorry, I'm below the screen. Have a margin of error of 2%. Also fine to say plus or minus 2%. Margin of error kind of goes hand in hand with the plus or minus. So you can either state it or not. Okay. Okay, so one more thing in lesson 1 here, and that is finding the z-stars. Oh, actually, sorry, there's 2 more things because I want to go over the technology page. Let's do the critical z-values first because I've been talking about that. I had you write these down at the end of class in case you didn't. Here they are. And I want to show you how we get that. Instead of using a table, I want to use Staplet because it's so much faster and easier. And so on the technology handout that I gave you last time, there's instructions on how to do it. So let's do these together, okay? So this time, instead of finding an area, our confidence level is actually the area. So for example, to get 95% confidence, we want to capture the middle 95% of the area. And so we need to see, well, what's the z-score there? How many standard errors do we need to go out? And it's 1.96. So you can see it's really close to 2. So let me show you how I got that, and we'll fill in this table here. Okay. So I'm going to go to Staplet, and I'll put the link in D2L. I have a bookmark right here. In case you're ever at staplet.com, I'm in this probability area with normal distributions right here. But I'll give you the direct link as well. Okay, in normal distributions, there's 2 operations. Calculate an area is to find a probability. We want a value because we want that critical z value. And because it's z, that means we are in the standard normal, which has a mean of 0 and a standard deviation of 1. So I'm going to enter 0, 1 and click plot distribution. So here's my standard normal. And then we are going to do central because we want that middle 90%. Well, let's do 95 first. I'll show you how we get that one. And then calculate values. Then it does give the values down here, or you can click show labels on plot. I like seeing the labels. It's a good visual. So here we can see if we go out 1 standard deviation, or in this case standard error, because we're talking about sampling distributions, almost 2 standard errors. So 1.96 standard errors on both sides will give us the middle 95%. Okay, so that's what we want for a 95% confidence interval. So that's why we go out 1.96 standard errors. Okay, so let me write this on here. 95% is 1.96. Okay, you might be wondering why I'm just writing the positive and not the negative. The plus or minus is already in the formula, so we'll be doing the plus and the minus as part of our formula, okay? Okay, and then to get a different one, so let's try 80. We change this central area to 0.8. So 80 is smaller, right? So it's going to be narrower. For that, we only need to go out 1.2816 standard errors, right? If we want to be less confident, we can actually be more, we can have a tighter interval. If we want to be more confident, we have to have a wider interval. So this is going to be 1.2816. Let me write that down first. .2816 for 80% confidence. Now I'm going to do 0.90. Should be a little wider, right? Because 90 is a little wider than 80. 1.6449. And then let's go ahead and just do 0.99. Now this one's wider, right? So this should be quite a bit wider, but we know 99.7 is 3. So it should be somewhere between 2 and 3, right? Let's see how far out it goes. Okay, 2.5758. Hopefully these numbers look a little familiar to you, but if not, that's okay. Okay, so keep this paper handy or your other set on your notes, because depending on which confidence level you'll be using these values. And then I usually have just one or so on the homework where you need to find your own z-value for practice. So let's say they give you a 92% or a 98%, then you can find it using this method. Okay. Okay, great. So that is that's how I got all these numbers right here. These are our critical Z scores, same numbers we just got, okay? One more thing, and you may have noticed it on the technology page on the bottom of the first page. There's also, and you may have done this in 243. I didn't do it in my classes, but you may have done it with some other instructors. There's also these theoretical calculators. So I want to show you how that works. So let's go back to, actually need to go back a page to where we found our confidence interval. So let's go back to example 8 here. And what this is it's a way to double check this, okay? But still using the theoretical method. It's not a simulation. This is also called the theoretical method because we're using the normal distribution here. So I'm going to write on the side here, theoretical calculator. And this is a check. Okay, and the one, so I'm going to go like this. The one we're actually going to use is GeoGebra. Okay, so let me go to GeoGebra here and show you. So you may have used GeoGebra to find normal probabilities, and that's great. This calculator works just fine. It's a normal probability calculator. The reason I like Staplet is because it labels the horizontal scale correctly. Notice how this scale should be going by the standard deviation, but it's not. Okay. So you're welcome to use this for a calculator if you prefer, but just don't use it to copy graphs from. Use Staplet if you're going to use an image, insert a graph. Well, so this is the distribution area. We're going to go to the statistics tab. And I'll show you, if you haven't seen this, I hope you really like it because it's a really quick way to check your work. So first we need to select the thing that we're doing, and we're going to be doing a lot of these things in this class. So we are actually doing an estimate. So a confidence interval is an estimate. And we're in a proportion, z estimate of a proportion. Okay, and let me show you on the notes page so you know what you have to work with. So I have the link right here, and I have the link in D2L. So we went to that link, and then we select the statistics tab. So we did that. And then we're selecting z estimate of a proportion. Okay, then we're going to enter our confidence level. So the next thing on here is it asks for a confidence level. So we did a 0.95, which is the default. If we had a different one, we would need to change that. Okay, then it says enter the sample proportion, and then the results just appear below. So we had, remember this is our p-hat, we had 97 out of 112 students who bought the books with the credit card. So I'm going to enter, it puts question marks to start with. So I'm going to enter 97 out of 112, and let's see what it gives us. It says success is 97, that's what we had, n is 112. Our standard error is 0.0322, that's just the square root part. Our lower limit, our upper limit, and then the interval, which kind of says the same. Well, actually, this is our interval, and if we subtract it, we get the lower limit. If we add, we get the upper limit. Okay, so let's compare this. I've got it on the notes page right here. So this is our interval, or this is the part p hat plus or minus the margin of error. So let's see how this compares to what we got. So we got 0.8661 plus or minus 0.0631. Amazing. And our lower limit was 0.803, and our upper limit was 0.929. We got 9292, they got 9291. One thing to know about these calculators is sometimes they are off by a digit or two, and it happens, I think, because they might use a different number of decimal places for either p hat or z star. I've just noticed they tend to be a little bit off. So it's kind of a general check, but you will need to show your work. You know, if it asks to use the theoretical method, please do show your steps. But then there might be a question. I know there's a question in My Open Math that says use the theoretical calculator. Okay? So we've got, in general, we're going to have 3 ways of doing things. And I know it's a lot, so we're going to be practicing as we go throughout the term. We're going to have a lot more practice. There's the theoretical method with the formulas. There's the simulation, which we did bootstrapping, and we'll do more simulations. And then there's the theoretical calculator, which is this. So these two should match pretty closely. The simulation will have more variation in its answers because that's a different method that has just taking different random samples, so there will always be more variation in that method. Okay? Okay, great. So I hope that gives you enough to finish up your Lesson 1 homework in My Open Math and then work on the team assignment. We'll still have next class where you can ask questions. So do as much as you can. Save those last questions, either post on the forums or bring them to class, or both, and then you can finish up that homework. Okay, I'll work on the Lesson 2 video and I'll post that when it's ready. Okay, and I'll see you when we have class again. Bye-bye.